Hello, everyone. I'm Mike Zawalski from LRS. Thank you for making time out of your day to come and join us. This is the final episode in an LRS sponsored series called Flash Forward, where we are highlighting the IBM Flash Systems family. For those of you who maybe didn't get to all the sessions, we did have a couple of very technical webinars. We've had a half a dozen blogs and vlogs on the topic. And in conclusion for our series, we decided to take something a little more lighthearted and kind of sum things up with the theory that, maybe if you laugh a little when we're reminding you of all the stuff we've taught you, you might actually remember some of it. So garage logic is pretty prevalent out there on the internet. And so we decided to try something different called Fishhouse logic. I live in the great state of Minnesota, which is white and snow covered half the year. And we actually go out onto the lakes in the winter and we drill holes in the ice, which is, up to 2 feet thick sometimes. And we fish for fish when it's 20 below zero outside. The picture that you're looking at is a picture of an ice town. And as you can see, we drive our cars right onto the lakes. We bring generators so we can have a little neon palm trees and other tasteless decorations that denote our fish house from, the guy next to us. So what we're going to do is try to talk about the Flash System family, and I'll try to weave a little bit of fish house humor into it and maybe teach you guys a few things about the Great White North up in Minnesota as well. Thanks for joining us. Many of you will remember in Field of Dreams, James Earl Jones, with that wonderful voice of his, telling Ray that if you build it, they will come. Now, he was talking about baseball fans, but it's a statement that's a takeoff on an even older saying that many of us had growing up. And that was that if you build a better mousetrap, the world will beat a path to your doorstep. And the thought was that if you built a really good product, the word will get out. I'm here to argue that the IBM Flash system is just such a product, and that you would all have it installed today, except for the fact that something happened on the way. And that something that happened was social media. And it turned the world upside down. First off, we have a whole generation of people whose thumbs are incredibly versatile because that's all they use anymore. But we also have a case where even though social media hasn't taught the lame how to leap, it has taught the stupid how to speak. And this is a great caption from The Wizard of Oz. For any of you who don't recognize it, the scarecrow didn't have a brain, didn't keep him from talking. It turns out Facebook have enabled a lot of people who don't have brains to just keep on talking. And as a result, people are way too busy. They got way too many social feeds. They're inundated or they're drowning outright in their messaging. And what that means at work is that people are too busy to stop and look and think. And business as usual usually just wins by default. So whatever you bought last time is most likely what you're going to buy next time because you don't have the time to go into it. To make it worse, vendors have quit calling on their customers face to face, and they've resorted to marketing through social media. And even the vendors who do try to get in front of customers don't have the time to spend in front of them. And that's unfortunate because what it means is instead of really understanding products, what matters now is the person with the largest loudspeaker usually wins. So it isn't anymore about building or having the best mousetrap. What it's now become is telling everyone that you have the best mousetrap over and over and over and over, and eventually you just beat them down and win by default. So against that background and the fact that we've already reviewed all the technical stuff about this product, I'm going to fall back to a presentation that's just meat and potatoes. Try to put it in simple English. try to summarize the performance, the cost, and appeal to all of your respective common sense. Okay, well, I'm a little old. Sometimes I forget what I was talking about. What were we talking about? Open system storage, block storage in particular. For those of you who maybe don't recall, block storage is the underlying technology that drives businesses vis-a-vis the hardware that all major databases run on. And the reason is it delivers an unmatched level of performance that other technologies don't. Now, one of the things about IBM philosophy that's different is that IBM believes in best of breed solutions for the markets that they compete in. They don't use what I call least common denominator technology. And what I mean by that is they don't build a product that's okay at 10 different things and excellent at none of them. They build a technology that's built for doing something and it's excellent at it. And that's a different philosophy than a lot of people use. I hear coming into work in the morning, we have storage for everything you need and it all looks the same no matter where you run it. And I think it must be functionally crap because there's no way you could deliver that to everybody unless you deliver just bare minimum functions. So IBM says, for the block environment, we're going to provide one single family of products, and it's called the flash system family. They're all built on the same technology. They're functionally identical, common management interface from top to bottom. They're faster and functionally superior than any of their competitors and typically come in at about 1/3 lower cost when you look at total cost of ownership. I'm also going to talk about some cyber resiliency capability that none of IBM's competition offers. I'm going to go through several big ideas in this presentation, but the first big idea, if you walk away with nothing but my 4 or 5 main points, the first big idea is best of breed solutions for all the markets that you're in. We do not pretend to be a jack of all trades. Here's 4 major markets that IBM competes in. 2 of them are in the mainframe space, 2 of them are in the open storage space. And in the open space, you see that block storage has flash system by it, and file and object storage use counterpart products from IBM called Scale or Fusion. The reason I'm pointing this out is it isn't just this area, it's the whole product portfolio. Every major market has a product optimized for that space, for functionality, price, and performance. And we won't go into it today, but in all 4 of these categories, IBM has leadership awards for the technology that it brings to bear in that respective market. Now, why again does IBM do that? The bad guys have kind of a Swiss Army knife approach. And if you're ice fishing, it's great to have a Swiss Army knife because you can open a bottle of beer or you could open a bottle of wine. But if you actually catch fish and you want to fillet the fish, that knife isn't worth crap. You want a knife that was designed for filleting fish. And going back to IBM's philosophy for each of its markets, we give you tools that are optimized for the market that you're in versus generalized tools that are kind of mediocre at everything they do. And you might think, I don't know if that really applies. Reminds me of a friend of mine in a movie. Hopefully you guys remember that. A kid in Crocodile Dundee pulled out a pocket knife and Mr. Dundee pulled out a real knife. That's a great case where it's better to have an optimized knife instead of a pocket knife that's capable of opening bottles. So the knife that IBM chooses for its open systems block storage is the IBM Flash System products. And we're going to dive into those now in a little more detail. The design of the products was to be intuitive to customers. So as the numbers get bigger on the model, the performance and the throughput and the capacity all also get larger. These are all pizza boxes in my mind. They fit into industry standard 19-inch racks. And basically from the 5300 up to the 9500, we have high performance storage. And below that, with the Charlie 200 model, we have capacity storage. Typical capacities here, and you're going to see that as you go up from the 5300 to the 7300 to the 9500, things generally double. You go from under a petabyte to up to 4 petabytes of usable capacity on the 9500. And it's interesting to note that on all these boxes, you don't have to buy them full. You can buy them with 2 flash cards in them, and you can grow them 1 card at a time. So for small customers or small applications, you do not have to make huge capital investments right out of the chute. They're very granular. If you look at the gigabytes per second that these are capable of delivering, you see, as I mentioned earlier, as you go up from the 5300 up, it's kind of a doubling. Not exactly, but pretty close. And as you go into IOPS, you see the same thing. The bigger the box, handles more throughput, more IOPS. The latency, which also matters, is sub-millisecond on all the performance models and roughly a millisecond on the capacity model. Now, when I say sub-millisecond, it's about 40 microseconds on the faster products, on the top 3. And that, by the way, is the best in the industry. And when you look at cost, you can see why we have capacity models and why we have performance models. The bottom line, in case you're wondering, the FS5000, that's an older product that was a capacity offering that had spinning disk in it. And I offer it to give you a reference point for the cost of flash versus the cost of spinning disk. And it is, I think, interesting to note that the cost per terabyte isn't that different on the various models. Which brings me to big idea number 2. It's very simple. You just decide how much performance you need, whether it's IOPS or gigabytes per second, and there's a model that matches it. And from a single pane of glass, you can manage all these models, because they all run the same operating system under the covers. So if you can't go to who you're buying from today, and you can't look at their product's performance and end user cost in less than 5 minutes, then they're keeping something away from you, and that should be a flag. In terms of capacity on these boxes, I mentioned you can grow them 1 card at a time. I'm going to talk also about the benefit of active controllers, but I'll talk about that in more detail. But suffice it to say that IBM, because of its mainframe experience, knows how to do large amounts of concurrent processing. And IBM can take 2 controllers and have them both be active and working in concert with one another and get almost twice the performance of a single controller. It turns out that if you had 2 units that could each, say, do 10 units of work each, you won't quite get 20 units when you lash them together, but you'll get 19. You'll get very close to double the throughput. And that's relevant because a lot of the controllers in the market today, they use active-passive, which means they're slow, half the speed as a result. We don't really care whether you prefer CapEx or OpEx because there are options available for both. Whatever your company prefers to spend, there's a model that'll help you get to that, and a purchase model is what I'm referring to. Some people like the pure evergreen subscription service. Other people are starting to wonder what they signed up for. But if you want it, understand that the Flash System family has a comparable option. As I mentioned earlier, we're only talking about block storage. But for the Flash System, whether you run it on-prem, whether you run it in a colo, or whether you run it in the cloud, it looks all the same. And if you have other non-IBM block storage again that you're thinking you've already got investments in, That can be virtualized behind the flash system family and managed as basically a series of, forgive me, but dumb disks. So it can be made to look like auxiliary flash system storage and take advantage of all the function that the flash system product offers. Another thing people don't think about, but IBM has the densest footprint and the lowest energy cost per terabyte in the industry. And you may not care, but right behind maintenance, the biggest single cost is energy. Colos care. And I suspect the day will come when they'll quit charging per rack and start charging for how much heat your rack generates and how much power it requires, because it matters for the big customers. Now, the ultimate thing that differentiates the flash system product is called the flash core module. And basically everybody in the industry uses flashcards. NVMe is just the standard that everybody follows. And oh, by the way, IBM helped develop. And that's what you see on the bottom half of the screen. On the top half of the screen, you see a flash core module, and you're seeing those same chunks of memory, but you're seeing them placed on a much larger chip with processing power to supplement that memory. So if you think about like a candy bar and a wrapper that you'd put around a candy bar to keep it clean, flash core module is a wrapper that you put around your flash memory to add function and add performance, and can do the work that storage controllers would otherwise have to do. And I'll show you why that matters. So if you compare an industry standard NVMe card versus an NVMe card slipped into a flash core module wrapper, it's like comparing a propeller plane against a jet engine plane. It is not a very fair fight. That's an F-34 for anyone cares. What does it do? Well, one of the things it does is online data compression all the time at wire speed. Wire speed means no performance impact. It also does always on data at rest encryption, also at wire speed. Now, if you're not having these problems, you know customers who are. People who have to shut off data compression during their busy times because the controllers can't handle processing your data and compressing it. So they process it first, then they compress it in a second pass at the data. Same is true for encryption. With this product, because of that extra processing power that's on every single flash card wrapper, those functions are entirely offloaded. Therefore, they're always turned on. And even if you were to disable them, which they do at the lab just for fun, it doesn't change the performance. That's how much extra power is delivered in the form of these flash core modules. Now, a third thing that is also unique is IBM provides with the 4th generation of the flash core module online immediate threat detection. If they see as an example that you have data that is being encrypted, it will phone home to IBM to its security center, and it will provide warnings to your SIM or your SOC or whoever you guys have. It'll say, guys, we're under attack. And we have cases where customers have been called by IBM and told that they're under attack before their own internal folks have even realized it was happening. So you say, well, does that make a big difference? And the answer is, yeah, it does. You might lose a dozen or 100 LUNs before it's detected, as opposed to maybe 1,000 or 10,000 LUNs if it's not detected. So your recovery action's dramatically reduced if you can find it sooner. And oh, by the way, that is a standard feature of the product. So what you have, unlike normal flash, you have what is called computational storage. As you scale your storage, you scale the processing power associated with that storage. And the flash core module is IBM's third big idea. Now, in addition to protecting your data, the flash systems also provide, as a standard feature, the ability to create safeguarded, or more commonly called immutable copies. It's a standard feature. These are on array copies, so that if you're under attack and you need to recover, you don't have to bring them back from a cloud location over a network. They're physically resident on the same array. What safeguarded copies does is it makes a point-in-time copy. It takes it offline to users and your host operating system and fences it so that it cannot be touched by anyone else or even be visible by anyone else. IBM also employs a methodology called the Cyber Vault, where their recommendations are that you proactively test these copies. So rather than wait for a disaster to see if they're any good, you know they're good because you've tested them ahead of time. So you're making copies and you're validating that those copies are good. So what you're creating is a copy that the bad guys can't attack because the bad guys can't see it. And that is, as you might expect, another big idea. Now, most of you, or hopefully most of you, are enjoying free pizza, compliments of LRS and IBM. And as I think you might have seen in our invitation, when the lakes freeze over, people fish a good hunk of the night and they get hungry. And so clever entrepreneurs deliver pizzas on snowmobiles to people ice fishing in the middle of nowhere. And so I'm going to use a pizza box as a prop. And candy is also a great prop. It's important in the winter for quick energy. But if I take a 1U pizza box, that's a lot like a 1U server or storage controller. If I get deep dish, which is my preference, it's a deeper box, and it's a good example of what a standard 2U controller looks like. And a candy bar is a pretty good representation of a flash card, because remember I talked about the flash core module being a wrapper around the flash card. Well, candy bars have wrappers. The whole thing plays if you can follow what I'm thinking. So if we open up our pizza box, this is what a typical storage controller looks like under the covers. I went with holiday colors, red and green. You always have two controllers. Some people have them run active-active, as I've alluded to. Some people have them run active-passive, which means one just sits idle all the time waiting to jump in if it has to. There are bus connections that allow the interconnection of those two. And then in this case, because I only had so much room to work with, I showed a dozen slots for candy bars, even though, of course, we have models with 12, 24, 48 candy bar slots. It's easier to just show 12 of them in this example. So you haven't figured it out yet? I am working off a limited budget. Now, we talked earlier about these storage controllers and IBM's being active-active. One of the reasons IBM outruns its competition in terms of performance is that we have two boxes constantly running under the covers instead of one. And you might say, well, that's really good. And the competition says, that's great, but what if it breaks? If IBM loses one, their performance slows down. It's cut in half. And that's a true statement. What they don't mention, though, however, is that the rest of the year, we're running circles around them. So if you take a typical product today that has 6 nines availability, and if you don't know what that means, it means 99.9999% availability. That's pretty much an industry standard. So what if you went to Radio Shack or Best Buy and you just decided to build one of your own? And you could do this. And you, because you're building it at home, you can't build it quite as reliable. So all you can do is 4 nines availability. And you build this thing and it's only up 99.99% of the time. Well, that wouldn't be good enough for business, of course. But the reason I show that is even if you could only deliver 4 nines, which you could do with a soldering iron and an erector set if you tried. That's only 1 hour of downtime a year. So, philosophically, do you want to run twice as fast most of the year and then run as slow as the other guys 1 hour of the year? Or do you just want to run slow all the time, 365 days a year? When you look at it in that context, I think their argument about slowdowns is actually pretty foolish. So if we take the other guy's pizza box or their storage controller, let's now move from the controllers under the covers to the actual flashcards themselves. And in this case, we're going to stick 4 yellow candy bars in there, which would represent 4 flashcards. Now, flashcards are important because flashcards are what holds your storage. And if you don't have storage, you don't need a storage controller, right? So the ability to have flashcards is a really good thing. But when you add these flashcards with the other guy's stuff, the box doesn't run any faster because you add those flashcards. Those flashcards are simply storage, and that's all that they're capable of. When you look at IBM and you add 4 flashcards, you add 4 flashcard modules, which means you add processing power 4 more times. So you not only have controllers 1 and controllers 2, you have 4 additional modules in there that are taking care, as I mentioned earlier, of all the compression and all the compaction, freeing up controllers 1 and 2 to go do other higher valued tasks. And oh, by the way, nobody else does this today. Well, let's say you want to add 4 more. In their design, it's just a lot of capacity you're adding, but no more processing power. With the IBM design, you're not only adding capacity, but you're scaling processing power hand in hand with it. And then if you go back to my earlier argument about active-active versus active-passive, we've got 2 very fast controllers. They're both active all the time, and they're supplemented by all the flash core module processing power. And in simple layman's terms, this is the reason that the IBM box can run circles around anybody else's pizza box. And this is the argument that, in the simplest of terms, other people don't want you to look at. So if you put aside all the very, very technical stuff and just try to think about common sense, it's dense, it's compact, it's got the industry's lowest energy use. And if you don't believe me, by the way, and you shouldn't believe me on any of this, go do some homework. These numbers are all published from IBM and all of its competitors. You can validate every fact on this chart. IBM has the fastest box by far. With 40 microsecond latency, nobody else comes close. And that translates into highest IOPS. The last thing is, if you have anybody out there who is a bigot about their performance, you know what? IBM is not afraid of a benchmark. They have loaner units that they will ship on a heartbeat to anybody who wants to see one, and will compete head-on at any customer. I mentioned earlier that there's a single, simple interface. Now, one of the guys, Pure, they advertise that a 12-year-old can set up their systems. And I guess that's an okay claim, but in Minnesota, it's against a lot of higher 12-year-olds. So we designed a system that a high school graduate could work on, because high school graduates are legal hires. And it's simple enough for a high school graduate with a little bit of training. So is it quite as simple as Pure? I don't know. Is it complicated? Definitely not. If you want long-term lock-ins to get better performance, you certainly can get them. Pure's great at them. We can offer them too if you want it, but we think they're kind of stupid. And so we think it's a better value not to have lock-ins. All of our stuff is active-active by design. You can't shut it off and make it active-passive if you want to. Nobody builds high-end processors better than IBM, so nobody has the expertise that IBM has. at interchange and interconnect and making things work well hand in hand. Nobody else does full-time compression and encryption. And oh, by the way, if you get better than 3-to-1 compression with our product, that's free capacity. We don't raise your license because there is no license by terabyte for capacity. And you might have noticed one of my earlier big ideas was on-array immutable copy protection. If IBM sets up your safeguarded copies, IBM will guarantee your recovery time in a cyber attack. So as we would say in the Fishhouse when the line starts tugging, what are you waiting for? Set the hook. At this point, I will quit jabbering and we'll open up for questions. Thank you all.